All right, so this section is going to talk about the actual SSM protocol that the AccessPort is talking. Like, we're going to talk about pretty quickly what the packets are, how they're structured. I'll get into some examples about the captures that you probably would have by now if you have been doing CANBUS captures. So this is more or less going to be the Subaru SSM protocol. There's nothing to say that this is not how other cars act when you're talking about the AccessPort data, but this is going to be specific to kind of what the SSM protocol is over OBD. I will also talk about the ISOTP protocol. I don't know if protocol is the right word, but it's a standard, and that's effectively how you're going to send multiple lines of data at once. So CANBUS can only take 8 bytes by default, but there's this little trick with ISOTP, and you can actually send multiple lines of request at the same time. This is obviously an example of a receive, but long story short, when you start looking at AccessPort data, you're going to see the requests are multiple lines. So let's just jump into it real quick. So again, this is from the ROM Raider basically source pulled off the internet. You're going to also see some more ROM Raider stuff when we talk about how to actually decipher and convert the values you get back into real world numbers that you can display on a gauge and stuff. So ROM Raider is pretty awesome. It's full of a lot of tuners, and so a lot of them have done the work for you, which is great. So what we're looking at here is this is an old school SSM protocol document. So this is basically over K-line serial. So it kind of relates to what we're doing with OBD, but there's a little nuances to it. The main thing you want to know is there are commands that you send. So you've got read, 2 different types of reads, and you've got writes, and then you've got an initialize. I've never actually used this, and that's annoying. And the writes I'm not actually going into right now either. Long story short, COB does not let you turn off codes like the 420 code for a cat error, and so you might throw a check engine light. This is most likely going to solve that problem. So I'm waiting for that light to actually come on to see if I can confirm that, but I might actually be able to bypass what COB says you can't do anymore and do it myself and basically write that memory block and turn things off. What we care about is reading memory. So what the AccessPort is going to be doing, I shouldn't have clicked on that. What the AccessPort is going to be doing is it's actually going to be doing an A8 command, which is read single address. Now it's a little misleading because you're actually reading multiple addresses at once, but all you care about is sending an A8 command when we talk about the packets and what they actually look like when you send them. A0 is if you want to read a large block of data at once. So what we're actually doing is we're actually reading single memory blocks, and we're reading them in a row, and we're getting them all back and then parsing them basically as individual items, converting them into one. You can also read like a huge block of data at once and get the results back, but all you really care about is that what we're doing is we're sending an A8 command, which is read. So that is basically all you're going to see on the actual AccessPort requests. So the next part about that is the actual request itself. So this is again, I'm going to switch to an Excel sheet in a second here, and I'll show you the real world examples of this. Long story short, you're going to send an A8, you're going to send a PP command, which is actually just 00, and then you're going to start sending your memory addresses. So the actual request is pretty simple. You have to send it a number of bytes, which is not included in here, and that will be in the kind of Excel sheet I'm about to show you in a second here. One of the biggest differences when we talk about what we're looking at with this PDF, this old school serial one, and the stuff we're doing over OBD is that in the serial command, you actually have to send like a checksum at the end of it to make sure everything is cool. You don't have to do that with OBD. You literally just send the commands all at once, and you get results back, and you hope they're accurate, but from what I've seen, they've actually worked every time. So in the end, all you care about is sending an A8 command, and that's what we're going to do next. and it's basically going to be direct reading of memory addresses on the ECU. It is going to respond with the values in each of those memory addresses. So what we're going to see is that in some cases, the actual value is just one memory address, which is super easy to deal with. In other cases, if you're trying to get a big number back or something, it's actually going to be multiple addresses at once, and you have to string those together and convert them into a value yourself in your code in the end. It's really not that bad once we start going into like how to figure out the size of things. But in the end, this is, long story short, we're sending A8 addresses or A8 address requests, and we're getting values back from there. So this PDF, it's, even though it's kind of dated and it's not 100% accurate for OBD, it still makes a lot of sense if you start looking at it and looking at your packets and stuff. And it actually really kind of, it took me a little bit of looking at this and looking at my data back and forth, but in the end, it did start to make sense, and it lets you figure out what you're looking at, because by default, you look at those captures from the AccessPort and they don't make any sense. So the second part of this process is to understand how you send more than 8 bytes of data with CANBUS frames. So you can only send 8 basically data packets at once. So there is a little standard here in 15765-2 basically called ISOTP, and this is a framework for how you send multiple lines of code, if you will, with CANBUS protocols and get responses back that are also multiple lines. So this lets you send 200 different bytes of data at once. And this is effectively what the CANBUS requests are using when the AccessPort makes them. So there's YouTube videos about this that kind of explain it a little bit more and are better at it. You don't necessarily, I'm not gonna make you an expert on it in this, but it helps to understand what we're looking at, and this will explain what we're about to look at with just an example request and response in a Excel spreadsheet. So long story short, you've got these code types, and this is effectively the first byte of data that you get in the actual data frame. You got a 0, 1, a 2, and a 3. All you need to know is that when you have a 2, which could be 21, 22, 23, etc., that is basically the order that you're getting your stuff in. So a 21 is the first one, 22 is the second, so on and so forth. When you reach the end, so it goes in hex basically, so when you get to the end and you're going to roll over to 30, you actually send a 20 and then you start with 21 again. That's when you're capturing like large amounts of data and stuff like that. But in the end, what we're going to look at right now is we're actually going to look at kind of an example request, and it's going to have these fields in them. You just don't really realize it until you actually look at something like this. So let's jump over to here. Here is an example request and response from the AccessPort, sending a couple gauges and getting the data back. This is in order that I am sending and receiving. So this is why I ended up going with something faster than an Arduino, is the raw data that you get is actually here, and it is not necessarily in order. Because look, I got a 30, I got a bunch of 21s, a 30. I'm missing data here, which is a big deal when trying to parse stuff together. Now, if you have a big capture, you can still figure it out. You can still figure out the order because these numbers are sequential, right? You can still come up with how it works. But if you're writing code and parsing this in real time, missing data is a problem. And it actually just, it makes everything take longer because you have to wait for the full order to come in. So when we talk about the ISOTP side, this 10 is always going to be the first one. So this is saying, I am starting to send commands to you. The second part of the request is a hex value of how many bytes am I sending you. So you're gonna know what you are sending over the wire here. Obviously, you can look at this request that it's making and you can see what it's doing basically. So this is saying I have 17 hex decimal, right? This is a hex value bytes after this to the end of my request. Now, 17 in hex equals 23. So what this means is that after this 17, I have 23 values that I'm sending it. And this includes the entire thing, basically. So this will also include the first kind of order number in this. So if you count these, there are 23 values in here until the end. It basically ends right here at this 08. So all of these are this is just a null value. So if you're sending a request, you need to fill in basically the whole packet. So even if you're at the end, you just fill it in with zeros, but you don't add those to the count here. You only add up the values that you're actually sending at that matter. So as we saw in the SSM protocol, I am sending an A8 command. So this first field here after the length is the command to the ECU. So an A8 is, if we go back to our trusty page here, is a read address. So I am telling the ECU that I want to read memory addresses. Now, right after the A8, you're always going to have a 0, because that is also part of this protocol here. It is basically this PP1, which single response, you don't have to worry about respond till interrupted, because you're never going to deal with that. This is basically saying you're always going to have a 00 after it. So the command is going to be what you want to do, which is read. You're going to have a 0, and then you're going to start feeding it values. Now, what you're seeing here are, you're going to basically have 3 bytes of data. So the Subaru ECU memory is a 3-byte, basically, register, if you will. So I'm saying I want to read FF6200, FF6201, 02. You can see kind of what it's doing here. And then it goes 0000E, then I'm reading F, and then I'm reading 00008. And then I'm done, right? This is the entire request. So you can see 7E0 is the access port sending this request. I've got my first frame, which has the 10, which is the start mechanism. How long my request is, my command, my empty padding here, and then all of the memory addresses I want to read. Now, when you send this request, it's going to respond in the order you sent it. So I wanted to read this memory address first. My response, when I parse it, is going to be, this is going to be the first one, this is going to be the second one, and so on. You know, you get the picture here. When we also talk about the ISOTP side is where you see this first, basically, byte here. And this is the order of operation. So if we go back to here, we can see this is a consecutive frame, which means it's got a 2 in it, and then the second part of it is the value. So I've got a 2, which means this is a consecutive frame, so it knows it was part of this request here. Basic, you know, it's easy to just remember it as it just goes up, right? It starts at 21, 22, 23, 24, 25, blah, blah, blah. That is the order of your request. And so when you send them with your code, you know, you basically form these commands yourself and you send them with this value in it. This is the entire thing. You're going to send it manually. So this is telling it, hey, I want to read all these memory addresses. When I'm done, the ECU, which is E8, it responds with its own response saying 10, which is like, hey, okay, this is my start of the response. It's telling me there are 8 bytes in this response after the 8. E8 means this was a success. You should pretty much always get an E8. If you don't, you know, just drop the data, right? I've never not gotten an E8. And after that E8, you're going to get your pure data back. There is no padding in the response when you're looking at these like packets. So in the request, I've got my padding in there, and technically because it's actually defined up here as, where did it go? Single response. But my actual data back from the ECU, it's not going to have that. So basically you start, as soon as you reach the E8, you start reading these values directly. And this is returning the values of all these memory addresses that I had up there. So the one thing to note is that Here is one value, right? 00FF62, that is a 3-byte register to a memory address. The memory address, however, is only going to return 1 byte of data. So you're telling the ECU, I want to read this block of memory, which is a single byte. It is going to return a single byte. So your requests end up being a lot larger than your responses because of just the fact that you're getting the pure data back versus the actual like pointer to that data, if you will. So even though these are all zeros, this is because the car is basically like turned off. So there's a reason why I'm not getting any like real data back for some of these things. But as you can see, I've got my these are the pointers to the memory. Every one of these 3 bytes correlates in order to the bytes that I'm getting back. And that's a big deal when you're trying to parse it. And I will get into that later, basically. So what we've got here is we've got our response and we got a bunch of zeros. We got a 3F in there. So I am getting something back, which proves that it is working, and then some more zeros. Again, if you look at this, I've got an 8 in here, so I only need to read 8 of these back, So you've got what, 5 right here, 6, 7, 8. So there's also some padding in here, or null values just to fill in the frame. So you want to make sure when you're looking at these captures is you're reading the second value after the 10, because that tells you how many bytes you're sending. That way, when you're looking at the last frame, you're not accidentally thinking this is 0800 or something like that, right? You know exactly when it ends. You know the memory addresses are 3 bytes long. You can then walk backwards and figure out all of the addresses it's responding to. And then you can look at the response and you can figure out what the values are coming back. Again, all zeros don't mean anything, and this 3F doesn't mean anything either to you yet, because this is just this value is not basically like the real deal. It is just what the ECU is responding. Sometimes you have to do calculations on it to make it into a real number, and that's where we'll get into like the ROM Raider basically cheat sheet, if you will. Now, if you looked at the protocol here, you also see something called a control frame, which is a 3. These are the 30s you're seeing here, and these are pretty important. So how this works, and when you write your code, you basically can account for this in a number of different ways. I pretty much just kind of put some delays in there and stuff, but if 70 is your response, you send this first data packet. The ECU is going to say 30, which all zeros in here means, hey, I'm good, keep going. You send the rest of your data immediately. You don't need to like have any delays in there. You just pump it across the wire. When you're done, since it knows you sent 23 bytes, when that final frame goes, the ECU comes back and says, hey, here's my response. It's going to be 8 bytes long. It's got a 10 in here, so you know that basically it's going to have more stuff after it. I have to send another 30 as well, telling the ECU, I'm ready, give me the rest of your data. You can actually like play with this a little bit, and if you kind of look into how this stuff works, how the flow control works, you could actually tell the ECU to hold off, don't send it yet, have a delay in between the sends. In reality, if you're using a controller that's fast enough, you don't need to do that. So this 30 is basically saying, give me the rest of the data back. What you'll find is if you're just playing with this stuff and you're not sending this 30 in the right place, you will get the first piece of data back and you will not get anything else back. That's what I ran into originally, is I was sending requests and I was actually getting this 10 back, but I was never getting the rest of the data back. And that's because originally I thought the 30 was like at the end, and it wasn't until I started really figuring out what the heck was going on that I realized that no, 30 is technically the last packet you should send the ECU. So when you're writing your code, you send your first frame. I usually put like a delay of like 50 or something like that. I put a super small delay in here so that there's enough time for the ECU to give me my 30 back. I send the rest of the data, and then what I do is I actually just send a 30 right off the bat because I know the ECU is going to start sending me data back. So your request, when you're actually sending code, is going to be all of this yellow here, and it's going to be just like this. And you're going to, when you're capturing data, you basically, when you're looking at 30s here, if it has anything other than a 3 and all zeros, I actually just exit the loop and I stop because something went wrong. I've never had that happen, but I just assume I'm getting a 30 back, and that's why I have a little bit of a delay in there just to account for it. And then the ECU sends me my data back and everything is cool. And so what I know actually in my code is that when I get a 30 back, that means I have seen the entirety of the response, because that means I'm actually starting to send my next request, if that makes any sense. In the code, it might make sense once we get to that point. But I know that when I get a 30 back, that means my loop that is sending these requests has finished and I'm getting data back. I've gotten all the packets back. I'm good. I'm starting the next one, starting that loop over and over and over again. So what your access port is technically doing is it's technically sending these same requests for the gauges over and over and over. It's getting this data back, parsing it and displaying it as a value basically.